What is a force? In the simplest terms, a force is a push or a pull. You apply a force to an object, and so there are different types of forces that we talk about. The two types of forces are contact forces and action at a distance forces, or non-contact. So contact forces just mean that objects need to be touching in order for them to apply a force. Think like friction is a surface that applies a force to another object. Like those two objects have to be in contact with each other. Tension forces, those are like ropes and strings. So you can pull on a tension force, but you can't push with a tension because the string goes like this. The normal force, this is oftentimes called the support force. And it's called the normal force because it acts perpendicular or normal to a surface. And so if this is a table and I have a book here, there is a force on the book by the table. That force points upwards. That's the normal force. The support force, the thing that holds it up. As compared to the gravitational force, that's the force that pulls down on the object. The force on the book by the earth. Air resistance, again, we're not going to talk about this one too much, but it's a specific type of frictional force that has to do with air. Spring force, this is obviously when you come in contact or have springs that are shooting things. This is what a spring looks like. The applied force is just a catch-all for every other force that you don't have a particular name for. So if a person pushes on something, that's the applied force. And so if I have a box and I have a person here and they are pushing on this box across the floor, and I were to talk about all of the forces on the box, I would have the force of gravity pulling down, the normal force or the support force pushing up, and then I have the applied force by the person this way. Notice, we'll get here, but notice there's two different ways that I've labeled. I've labeled this way, on by the force on the book by the table, and this way, it's a little bit shorter hand, just labeling the type of force. Okay, action at a distance forces, non-contact forces, these are gravity. The electrical force, that's like the force that two electrons might feel that would want them to move away from each other, or a proton and an electron that want them to move towards each other. So that's the electrical force. And magnetic force, that magnets, right? North-south forces. Okay, so we cannot talk about forces without talking about mass versus weight, because weight is a specific thing. Weight is also known as the force of gravity. This is the weight, force of gravity. Okay, so how do you calculate that? The force of gravity, or the weight, is just the mass of the object times the gravitational field strength. So it was important last unit that we talked about this G as being positive, because when we talk about the force of gravity or the weight of an object, this is going to be a positive number that then when we decide which is positive and negative directions, then we will assign a positive or negative sign to the force of gravity. The mass, just the amount of matter in an object. So the mass never changes, but the weight will change. Okay, so if I went to the moon, the gravitational field strength, G, would change. That would change my weight, but my mass never changes. So mass is constant. Weight depends on G. A big thing with forces is summing the forces or finding the net force. We're going to talk about that later in this topic section. The net force just means the total force, or the sum of the forces. That sum of the forces is, we use this idea of the sigma. This is the Greek letter. It just means sum. So all of these things, net force, total force, sum of the forces, or sigma F, these all mean the same thing. Now, when we talk about the forces on an object, the important thing to note is whether the forces are balanced or whether the forces are unbalanced. Unbalanced forces cause a change in motion, meaning that object will speed up, it'll slow down, it will be accelerating. Balanced, when the forces are balanced, that is, we call that as the object being in equilibrium. There's two ways to have equilibrium. That's static equilibrium, meaning an object is stationary. So I have a book on a table and the force of gravity pulls it downward. The normal force or the support force is pushing upward on it, holding it up. These forces are balanced. This object is in static equilibrium. Now let's say just as above, I have a person and that person is going to push on this box. I'm going to put these next two forces in a different color. That applied force is this way. Now if the box does not move, that means we're going to have a frictional force going backwards. Okay, so the force of friction, this is important. F sub F, or force of friction. This force is always parallel to a surface. It's parallel to the surface, and then it's always opposite the direction of motion, or it's opposite the applied force, opposite direction of motion, or applied force. Okay. So the force of friction, notice the left forces balance the right forces and the up forces balance the down forces. This object is in static equilibrium. It's stationary. The other kind of equilibrium we can have is dynamic. So think of a bowling ball that's rolling down an alley, like the bowling alley. This bowling ball, rolling down this bowling alley, nobody's pushing on it, nobody's pulling on it, so it's going to have a constant velocity. There's nothing pushing or pulling it, so V is going to be constant. And the forces acting on it, well, that's just gravity downward and the normal force upward. There are no other forces acting on this ball as it's rolling. You could say friction, but if we assume that friction is negligible, meaning basically zero, then there are no other forces pushing or pulling on it. The up forces equal the down forces. This is in equilibrium. It's in dynamic equilibrium because the forces are balanced and it's moving at a constant speed. So unbalanced forces cause a change in motion. So if there were friction, then that would be pointing in this direction, force of friction. Now our forces are unbalanced, so we're going to have a change in the motion. So I'm no longer in uniform motion, or the same thing, constant velocity. I will be accelerating, or in this case, you can use the word decelerating or slowing down.